The question was asked, is this power system vulnerable to a cyber attack? And the answer? Yes, you better believe it is. When we talk about cyber, we're talking about the computers and the networks that interconnect them. And Steinmetz Falls has got tens of thousands of computers that are all networked together in this smart grid, including the generators, battery chargers, the solar, the pumped hydro, the monitoring and control room. Now these are the computers that you would normally think about when you think of power system. But there's also computers and networks out here to monitor the power grid, and there's a smart meter on every town and business. In fact, in this town, we've mandated that all refrigerators, heaters, and heat pumps must be smart grid compatible so that we, the power company, can have fine control and shed loads where necessary. Regarding computers, let's not forget the banks of servers that collect all the data about the smart grid, including the generator and the usage for every individual user. Without a doubt, this is the most complex network on the island, and it is certainly vulnerable to cyber attack. It would take a course unto itself to explain why and how people attack the system. We don't have time for that right now, but what I am going to do is I'm going to tell you about a really bad day that happened at the power plant many years ago. This was a time before we understood cyber attacks, before we understood the necessity of hardening the system and adding fail-safes to protect when the computers went wrong. You could say that the door was wide open, and sure enough, somebody stepped in. To understand this cyber attack, we need to talk about generators and synchronization. On that particular day, we had 2 generators online. Each generator has its own circuit breaker. On this side, the circuit breakers are connected together and the resulting power heads off to town. You'll notice I'm using a one-line diagram here where each wire represents 3 wires for our 3-phase system. Our power plant uses synchronous generators. Each generator outputs a sinusoid. Now you'll notice that when the circuit breakers are both closed, the generators will be connected in parallel. And when you do that, they will be moving in lockstep. This is similar to 2 people riding a bicycle. Now that we have our bike, we can show the pedals and the chain that connects them together. When we have 2 generators, and the generators are working together to provide power to the town, it's very similar to Alice and Bob riding a bicycle. Both generators are moving in lockstep with each other. We talked about this amplitude up here, and we said that each generator by itself produces a sinusoid. Well, as soon as you close these 2 circuit breakers, the output of generator 1 is felt by generator 2 and vice versa. In fact, everywhere along this point is the same voltage. So the generators must be turning in lockstep with each other. Again, like Alice and Bob on the bicycle. And if all is working as it should, each generator is providing an equal amount of power to the town. And now let's talk about the tricky part. Let's suppose that generator 1 was online providing power to the town. And you wanted to put generator 2 online, which is to say you want to close the circuit breaker here on generator number 2. This would be like Alice and Bob on the bicycle. Suppose Alice is pedaling the bike all by herself and Bob has lifted his feet off the pedals. If Bob were to do something silly, like just at some random time slam his feet onto the pedals, maybe he'll get lucky. Maybe he'll be in phase like this. Or maybe he'll get very unlucky and he'll apply power out of phase. If he does that, it's going to hurt because Alice is pushing full forward and Bob at that moment in time is pushing full backwards. You end up with the same situation with the generator. We have to be careful because generator number 2's voltage could be anywhere. Maybe it's in phase like this, or maybe it's completely out of phase like that, or maybe it's somewhere in between. And we have to be careful that we close the breaker at the right time. You could have one generator at a positive maximum and the other generator could be at a negative maximum. This is a bad situation. They're effectively shorting each other out. Now that you have a better understanding of the generators, let's look at that cyber attack. So on this day, we had generator number 1 in parallel with generator number 2, and they were both providing power to the town. The cyber attackers found a way to get into the computer that controls the generators. Again, we weren't very careful back then. We didn't have any cybersecurity measures, and we didn't have the fail-safes that we have now. So they got into the system, and this is what they did. They opened the generator number 2 circuit breaker. This is not an ideal situation, but no damage has been done yet. All that happened is generator number 1 revved up and it took the load. Now our attackers do a bad thing. They close the circuit breaker on generator number 2. They get lucky. The system isn't that far out of phase. It's like Alice and Bob. Bob had his feet off the pedals because the circuit breaker was open, and when the circuit breaker was closed, Bob put his feet back on the pedals, and he was just a little bit out of sync. So there was a small jolt as he added power to the bicycle. Once again, they open the circuit breaker. Generator 1 takes the load. Everything is okay. But then they do one last thing. They close generator number 2 circuit breaker. And bang! A bunch of stuff happens all at the same time. The circuit breaker for generator number 2 goes up in a fireball. Generator 1, which had been turning, grinds to a stop. And generator number 2, the generator itself, this huge, massive machine, is literally ripped out of the floor, and the shaft of the generator is bent. For the next month, the town is on electrical rations. You see, this was before we had the pumped hydro and the solar panel. The only source of power they had was the old hydro plant. It took a month to get generator number 1 working. Generator number 2 was a complete loss, and it took half a year to get a replacement. Yep, that's what you call a bad day at the power plant. That's the day we got serious about cybersecurity. We hardened our systems to prevent attackers from getting in, and we modified the equipment with fail-safes to prevent this type of accident. We effectively closed the door, but that doesn't mean people aren't still trying to get in.